Footprint Ecological. Origin of the concept. The ecological footprint concept was introduced in the 1970s by William Rees to measure human demand on natural resources. In the 1990s, Rees, together with Mathis Wackernagel, refined the concept by quantifying the biologically productive land and water needed to produce what we consume and absorb our waste, especially CO2. Definition. This metric calculates the amount of productive land and water, in global hectares, required to support a population's resource use and waste generation. It provides a tangible way to compare our consumption patterns with Earth's regenerative capacity. Resource management and sustainability. By revealing the gap between consumption and nature's renewal, the ecological footprint helps policymakers and businesses design strategies to reduce environmental pressure. It also serves as a tool for sustainability assessment, education, and tracking progress over time. Calculating the ecological footprint. The calculation converts a country's or individual's resource consumption and waste into the area of productive land and sea. Key steps include conversion into land area using yield and equivalence factors, categorizing consumption and emissions by sectors, food, housing, transport, goods, services, and incorporating the carbon footprint by estimating the land required to absorb CO2. Video content.
The ecological footprint is a measure of human demand on Earth's ecosystem. It's expressed as the area of biologically productive land and water needed to support a population's consumption and absorb its waste. When a population's ecological footprint exceeds the available biocapacity, that shows unsustainable resource use. For example, many developed countries have ecological footprints that far exceed their territory's biocapacity. The UAE, with its high energy consumption and reliance on imported goods, has one of the world's largest per capita ecological footprints. In contrast, countries like Gabon have footprints smaller than their biocapacity, indicating more sustainable resource use. Calculating ecological footprints at various scales helps us identify unsustainable practices and guide policies towards more sustainable resource management, both at our individual and household level and for entire countries.
Conversion into land area. Raw consumption data is transformed into land area by applying yield factors, which reflect the productivity of different land types, and equivalence factors to standardize these areas into global hectares. Categorizing consumption and emissions. Human activities are grouped into sectors such as food, housing, transportation, and services. Trade adjustments, imports, exports are also considered to ensure a comprehensive evaluation of each sector's impact. Carbon footprint component. The carbon component estimates the area of forests or other ecosystems needed to absorb CO2 from fossil fuel combustion. This area is converted into global hectares using standardized factors. Factors: energy and transport. Energy consumption is pivotal. Fossil fuels require vast land areas and emit high levels of greenhouse gases, while renewable sources, solar, wind, hydro, have a lower ecological impact. Transportation, dominated by fossil fuel-dependent vehicles, significantly contributes to the footprint, but sustainable transport options can help mitigate this effect. Household energy, food, agriculture. High carbon energy use in homes increases the footprint. In food and agriculture, meat and dairy production are resource intensive and emit methane. Intensive industrial agriculture further degrades soil and water. Embracing plant-based diets, organic farming, and permaculture can reduce these pressures. Industry, packaging, and waste management. Industrial production uses large amounts of raw materials and energy, generating significant waste and emissions. A circular economy that emphasizes recycling and reuse helps lower this impact. Excessive packaging and single-use products further strain resources, while efficient waste management, reducing plastics and toxic wastes, can ease environmental pressure. Natural resources and biodiversity. Deforestation and land degradation due to agriculture, urbanization, and industry diminish Earth's biocapacity. Overuse and pollution of water resources worsen the situation. Conserving natural habitats and protecting biodiversity are essential to maintain ecosystem services and reduce our ecological footprint. Conclusion. Energy, transportation, food production, industry, waste, and conservation collectively determine our ecological footprint. By understanding and addressing these areas, we can work together to ensure that resource use remains within Earth's capacity to regenerate. Thank you for your time. Video content.
Water pollution occurs when harmful substances are added to our waterways, including ponds, rivers, lakes, and the ocean. Water pollutants include sewage, the wastewater from factories, the seepage of chemicals from farms and other agricultural activities, oil spills, marine debris, and the flow of stormwater from land to waterways. So, how does water pollution affect the environment? Water pollution is harmful to aquatic organisms. It can cause them to die, move to new environments, or change the balance of an entire aquatic ecosystem. Marine debris also has a direct effect on large aquatic vertebrates like seals, dolphins, and turtles. What can we do to reduce water pollution? Make sure sewage and wastewater is properly treated. Reduce the use of chemical fertilizers and pesticides on farms. Reduce our reliance on fossil fuels. Direct stormwater to treatment facilities